In today's session, we are going to take an indefinite integration problem. And here we can see the problem is a square root of 1 plus x square divided by 1 minus x square dx. In such kind of problems, we will try to remove the square root from the numerator and we will keep the denominator as it is. So to make it free from a square root in numerator, what we will do is we will just multiply and divide by a square root of 1 plus x square in numerator and denominator. So let's start with the solution. The given integration can be written as integral a square root of 1 plus x square divided by 1 minus x square into a square root of 1 plus x square divided by square root of 1 plus x square. Now we can see that from the numerator we can remove the square root sign, because the square root of 1 plus x square into a square root of 1 plus x square will become 1 plus x square. And after that we can take the help of substitution to solve this problem. So this can be written as 1 plus x square divided by 1 minus x square into a square root of 1 plus x square. Dx. So the given integration can be further written as 1 upon 1 minus x square, a square root of 1 plus x square, plus dx plus integration of x square divided by 1 minus x square into a square root of 1 plus x square. So what we have done is we have just separated it into two terms. Like in numerator it was 1 plus x square, so we have separated it like 1 and x square in different way. Now the given problem contains a second integral x square upon 1 minus x square into a square root of 1 plus x square. This can be written as 1 minus x square minus 1, and we can take negative sign out of the integration just to make it in simple form. So what we are going to do is we are just going to do some arrangement or modification in the second integral term. So we are just going to add plus 1 and subtract 1, just plus 1 and minus 1, so that the original term will remain same. So we are just going to add 1 and subtract 1 in the second integral term. Why we are going to do this? We can cancel the 1 minus x squared term in the denominator by simplifying the second integral term. So finally we are going to write down the second integral as minus of integral 1 minus x square minus 1. So the whole integration I, we are not going to do any kind of changes in the first integral term, so that will remain as it is, root over 1 plus x square, 1 upon 1 minus x square into root over 1 plus x square dx plus, we can take minus not plus, so let's make it minus integral 1 minus x square minus 1 divided by 1 minus x square over root 1 plus x square dx. Why we have done like this? In the second numerator, in the second integral term, we can separate 1 minus x square and 1, so that 1 minus x square term, which is already present in denominator, that will get cancelled out. So now this whole integral can be written as I1. I1 has been highlighted in red color. I1 minus second integral can be separated in two integral terms, 1 minus x square upon 1 minus x square into root under 1 plus x square dx, plus, minus minus, it will become plus 1 upon 1 minus x square into root over 1 plus x square dx. Okay, so this integral has been written like I equals I1 minus 1 minus x square upon 1 minus x square root under 1 plus x square plus integral 1 upon 1 minus x square root under 1 plus x square. Now 1 minus x square is getting cancelled out from the second integral term, and for now the third integral we can write down I1. So we can see that I1 and I1 become 2I1 minus integral of this can be written as log of x plus root over 1 plus x square according to a standard formula. So we have applied the standard formula in second integral, and I1 plus I1 became 2I1. Here I1 is equal to integral 1 upon 1 minus x square over root 1 plus x square over root 1 plus x square dx. So now what we will do is, now we will try to find out the value of integral I1, and after getting the value of integral I1, we will substitute that value in original equation. So this problem has been simplified very much till here. So after this, our main target is to find out the value of I1. So let's try to simplify the value of I1. So I1 is integration 1 upon 1 minus x square over root 1 plus x square. So now what we are going to do is to substitute x is equal to 1 by t. We have substituted here x is equal to 1 by t. Hence we got dx is equal to minus dt upon t square. So to make the given integration I1 into very much simplified form, just to convert the given integral into very much simplified form, we have substituted x is equal to 1 by t. So we have got dx is equal to minus dt upon t square. So the given integration will become minus dt upon t square upon 1 minus 1 by t square integral 1 plus 1 by t square. So we'll just simplify this integration. So we can see here, after taking t square LCM, t square in numerator and denominator will get cancelled out. So it is t square minus 1, a square root of t square plus 1 upon t square root is t, and now we can see that the t square in numerator and denominator is getting cancelled out. So after this substitution, we will simplify this given integral, and if required, we will substitute another substitution to make it more simplified integral. So we can see that t square is getting cancelled here. So we'll cancel the t square term. And the next t will come into the numerator along with dt. It will come into the numerator along with dt. So it become minus t dt divided by t square minus 1 into square root of t square plus 1. So now it can be written as t dt upon 1 minus t square into a square root of t square plus 1. What we have done is we have taken the negative sign which was present outside of the integration. We have taken that negative sign inside the integration. Now we can substitute t square plus 1 is equal to z square. To make it more simplified, 2 dt equals 2t dt equals 2z dz. So t dt can be written as z dz. Hence dt is equal to z dz divided by t dt will become equal to z dz. So now the given integration has become in the form of t dt divided by 1 minus bracket z square minus 1 into z. So with the help of substitution of t square plus 1 is equal to z square, we have got 2 dt dt is equal to 2z dz, and finally we got t dt is equal to z dz. So this is giving us integral t dt upon 1 minus z square minus 1 into z, which can be written as integral of z dz divided by 2 minus z square into z. So finally we can see that the numerator z and denominator z is getting cancelled out. The z present in numerator and denominator is getting cancelled out. So finally we are getting the integration as integral as dz divided by square root of 2 square minus z square, which is of the standard form. So now we can apply the formulae to get the value of this integration. We know that this is a standard form of integration, so it is a very easy task to integrate this given integral. So we will apply the standard formulae here to get the final answer for the integral I1. So now we are going to write down the value of integral I1. So applying the standard formulae, we will get the value as 1 upon 2 root 2 log of mod z plus square root of 2 divided by z minus square root of 2. So this is the result as per the standard formulae of integration of the format integration 1 upon integration dz upon a square minus z square. So finally this can be written as, we will substitute back the value of z here. So as per the assumption, z was square root of t square plus 1. So we'll substitute back the value square root of t square plus 1 at the place of z. So we are getting this value, this plus c. So finally we have got the integration as 1 by 2 root 2 log square root of t square plus 1 plus root 2 divided by square root of t square plus 1 minus root 2. So again we will substitute the value of t because t was also a substitution, and we can recall the value of t. So t was t in terms of, so substituting back the value of t, we are getting this because t was 1 by x. So we will substitute back the value of t, that was equal to 1 by x. So finally we got this format in terms of x. So now we will simplify this to get the final answer till I1. Hence finally we have got the answer as 1 by 2 root 2 into log of root under x square plus 1 plus root 2x divided by root under x square plus 1 minus root 2x plus c. So finally this is the answer. Now we can take one more problem for the self evaluation. Integral 1 upon x